Hello everyone, my name is Flavio Pereira. I'm part of the technical enablement team, and today we're going to cover the storage level 200 lesson. On the first lesson, I talked about NVMe devices, and then here we're going to cover the block storage side. So I'm going to give you a couple overview of block storage, some of the features and capabilities of that, and some numbers around performance for block storage too. So just to give a quick overview, block storage is the storage that you can attach to any compute instance that was launched in OCI. So if you need extra space, if you need extra storage, you can just create a block volume and then attach that over to your instance. Okay, so this is actually a storage that can hold applications, installations, or even binary of softwares on it. So it can go big. You can go from 50 gigabytes all the way to 32 terabytes of storage on your device. So you can support up to 32 volumes on each instance. So you can go all the way up to 1 petabyte of storage if you want, associated to your VM. Okay, of course, there's few things that was covered in 100 lesson, like schedule backups. You can do backup of the block volume. You can do also cross-region copy. You can copy one block from one region to another one. If you're creating a disaster recovery scenario, HA scenario as well, so you can have those copies over across regions. We're really proud of the performance on the block storage. I'm going to cover that in a few details on a few slides. So you'll be able to see the numbers and how we can get some performance metrics around the block storage as well. Okay, so one quick thing I want to touch here is some of the features around block storage. And the first one is the volume group. So volume group is a great feature inside of the block storage, so you can combine multiple volumes in order to take backups or clone of those volumes. So imagine a situation where you have your application with multiple block volumes associated to it, and then you have to create a backup of those volumes. So by the time you get to the fifth block, the first block was already updated with new content, new information, and then you lost track of that backup. So if you restore all those 5 volumes on your environment, probably one of the volumes will be out of sync, so you don't have all the data capture when you executed the backup. So the idea of volume group is to resolve that problem, right? So you can have multiple volume is associated to actually multiple instances. You have all instances up and running of your workload. Let's say you have a ERP application with middle tier database and a web application in front, and you have multiple volumes associated to that environment. You can just combine all those block volumes in one single volume and then just take a backup of it, right? You can also include the boot volume too. Of that, so you have a consistent backup across all the data that's actually stored inside of your VM. So from the boot volume and from the block volumes associated to that. You can do volume groups for coordinated backups. Then you can take a copy or a backup of this volume group and just restore that in a different availability domain for replicated environment. So if you want to create a test dev scenario, you can do that as well. If you just want to copy that data from one AD to another one, you can do this volume group coordinated backup. So again, just take a backup of all the volumes and just restore that on a different availability domain if you need it. You can also do clone, right? So same features you have for the regular block storage, you can do clone too. You can clone the entire volume group, replicated environments, and it's really fast, right? So you can have all these environment replicated for you to create a new scenario. So fairly easy to achieve that in replicated environment. All right, in terms of the block volume performance, you can also find the performance around IOPS, throughput, and latency. So those are the 3 aspects of the performance that is going to be measured against the block volume. So the block volume scales linearly per gigabyte on the storage. So that means if you increase the size of your storage, you're gonna get better performance. So that's the way it is. So if you deploy a 50 gigabyte storage, you're not gonna get the same performance if you're using a 1 terabyte volume. So 1 terabyte volume will give you more performance than the 50 gigabyte volume. So just keep that in mind. Throughput is also part of the performance metrics, but throughput it's actually tied to the VM shape. So depends on the shape you deploying. That's going to give you the network throughput of the network, right? And then that's gonna impact the storage as well. So keep in mind of that. And then when you deploy compute VM shape, make sure you're picking the right the right size for your application, the right size for your performance. You have to select the shape that will meet the requirements for you. The IOPS is actually independent of the instance shape or type. IOPS you can measure on any type of a VM shape that you're up and running, and that's going to give you the performance that we covered under the SLA for you. Okay. When you attach a block volume to an instance, there's two types of attachment you can do. You can do iSCSI or you can do paravirtualized. Right. So iSCSI usually get the better performance, especially when using bare metal server. You're gonna get the better performance there, and you can use paravirtualized attachment too. So paravirtualized give you flexibility in terms of the device, how the device will be presented to the operating system. There's a couple things you can take advantage, like the device path name that you can select and use will be automatically showing up there. If you're using iSCSI, you do have to execute the iSCSI commands inside of the operating system to get access to the device. Okay. Here's just a table that just give you a few numbers around throughput and IOPS, and it depends on the block size that was tested, the performance. So you can see the numbers just to give an idea of how much IOPS and throughput you can get on the block volume. Okay. This is actually showing some commands that you can execute it on your block volume to measure the performance. So if you're using the FIO command, and I use the FIO command against the NVMe device, you can do the same on the block storage. You can measure read-only, read-write, or read-write operations, and measure and see how many IOPS you can get on each device. We highly recommend it to do it so you can validate some of the tests and do some benchmarking around the block volume associated to your VM. Okay. More in terms of performance, like how you can get more information on it. There's a few links here. The documentation give you some of the guidance for you do some benchmarks as well. There's blogs that talks about the block volume performance, and some third-party reviews around block storage performance too. So people are checking our block volume, doing some benchmarks and present the results, so you can get more information and see how it can benefit from the performance around the block storage. Just a warning here, if you're doing some FIO commands benchmark, just be careful when you execute those. If you don't execute in a way or using the wrong parameters, you might just delete the data inside of the disk. So just be careful with that. We highly recommend you do the FIO when you don't have any data, when you just attach the volume and you want to just do a quick benchmark to see the performance. Highly recommended to do that without any data. So then it will be safe to execute this command. All right, so let me do a demo. Let's just show you how to attach block volume to the VM, how we can access. I'm gonna run some FIO commands to you so we can get information on terms of performance, and yeah, I'll show you how to do that. All right, so here I am on the OCI dashboard on the compute instance page, and I was provisioned the dense VM dense shape here, and I'm gonna attach a block volume to that shape so you can see how that works. So it was provisioned AD3 on Phoenix region. So in order to create a block volume, I go to the menu, block storage, and then I'm gonna go and create a block volume here. On the block volume, I will create data volume. on availability domain 3, which where my instance are it's running. I'm going to use 1 terabyte of that. I'm not going to select any backup policy, but I can, if I want, select one of the 3 options for backup policy. The encryption, I'm going to use the encrypted using Oracle managed keys, but if you want to use your encryption keys, you can do that too. You can select that one and select the vault of your encrypted keys, and just select the keys here, so the volume will be encrypted using your own key. Okay. Yeah, let's just create a volume. Oh, the name is required. It's data. Let's go here and create that volume. That's going to be provision, and here you can see the metrics. On the block volume page, you can also see the volume read throughput of your block, the read and write throughput, and operations too, read and write operations of the data. So that's give you a plenty information of what's happening inside of the block volume when you start putting some load and writing files and delete files and doing read and write operations on it. Okay, so from the block volume page, I can just go and attach an instance to that block, right? I can just say I want to attach the block volume to a specific instance, and once I do that, like I mentioned on the presentation, you have 2 types. You can do iSCSI or Power Virtualized. You can do some read-write operation or read-only, and there's one feature that's coming up, which is the read-write shareable as well. So we're going to use the read-write one, and I'm going to select the instance with the VM dense IO. And the device name, so I can pick a device name that I want to use it. For example, I can just use dev Oracle OCI, Oracle VDB. So that way, every time I rebooted the server, I rebooted that instance, this device name will be persistent. All right, so I'll be able to always use that device name once I rebooted the server. Okay, I'm going to use the iSCSI one, and I'll click attach. When I click attach, I got this message saying that if I want to add this iSCSI block volume that I just created and attach through on my instance, and make sure that I'll have access to that iSCSI volume when I rebooted the server, I can enter the information on the etcfs tab and make sure I add those options, the netdev and no fail option. So in case there's some problems reaching out the device, the machine will boot normally, right? Even if I don't have access to the block volume later on. Okay. So with that, I can see that's attached to my device. So let's just go here on the action and just open up the iSCSI commands information. I'm going to copy the iSCSI commands because I have to execute those commands inside of my my instance. So I'm just copy that, and let's go and access my instance. So if we go back here, and I actually have this up and running already. So this is my VM. If I do cat proc partitions, I don't see my extra block volume associated to that as yet. So if I do lsblk, I also don't see this information. So let me just execute the iSCSI commands, and now if I do lsblk, I can see the SDB device associated, 1 terabyte disk associated to that. Okay. Yeah, so the device name path that I decided for this, if I go back to the attached block volume, it's dev Oracle OCI, Oracle VDB. So if I copy that and go back here, I can check that I have this device enabled as well. So from here, it's easy. I can just create a directory, for example, and I can format that that device. I can do a mkfs, for example, xfs, and dev Oracle OCI, Oracle VDB, and just format the device on XFS, and I can mount that device as well. So if I do mount dev Oracle OCI, Oracle VDB, data, and then now I have 1 terabyte of volume mounted inside of my operating system. Okay, so this is one way to do it. I can also do the fio command just to test the performance. So if I have to do that, let's just do here real quick and find the fio command that was executed for the NVMe. But now we're gonna do that for /dev SDB, which is the device, the block volume that was associated to the machine. So if I run that command, it says mounted, so I need to unmount that. So let me just do that real quick. Unmount data, and I can execute it again, and now I'm going to start executing the process and collecting the information around IOPS. So I put 1 terabyte of block storage. Let's see the IOPS, how many IOPS I'm going to get on 1 terabyte data. So just give you a few minutes here, so I'll show you the results. All right, so it finished the test. So if we check the IOPS here, we can see that it was around 29K IOPS on the disk on the right. So yeah, so this is really close to the SLA that we are. It's actually under the SLA that we're providing. The SLA says 25K IOPS for 1 terabyte block volume. So yeah, you got the performance that we got the performance that we're expecting to it. Okay, so yeah, this is the demo. I hope you like it. Thanks for watching.